Alright, in this video we want to look at two different examples using the pressure in a fluid and the atmospheric pressure. So in our first example we want to look at the pressure on you when you're 2 meters below the water in a swimming pool and in the ocean. And so the key difference between these two pressures is going to be the density of the fluid. We defined the pressure in a liquid that the liquid exerts on an object as the rho of the fluid times the depth that it is below the water times gravity. And we'll assume that we're on the Earth, where it's at sea level, where its G is 9.8. So we have the 1,000 times our 2 meters times 9.8. So when we look at the pressure, we take our 1,000 times 9.8 times 2, and we get 19,600 pascals. Now when we can repeat this, but this time when we're in the salt water, we put in the 1030 for the density times the 2 times the 9.8. And when we do that, we do get, of course, a different number. The pressure is slightly increased because the density of the water is slightly larger. So this is just a simple example of looking at pressures in fluids related to the depth. And of course, as you go further into the water, you will get the pressure will increase with the depth, of course. Alright, so our next problem involves calculating the force on a table. And of course, this is going to be related to the pressure because we said that pressure is force over area. And the pressure that's on the table is going to come from the atmosphere. And we said the atmospheric pressure is 1.01 times 10 to the 5 pascals. So if we assume that this is the pressure exerted on our table, then our 1.01 times 10 to the 5 equals the force divided by the area of our table, which is our 1.7 times our 2.6, which gives us our 4.42 square meters. And so essentially the force that the atmosphere exerts on our table is quite large at 4.46 times 10 to the 5 newtons. So this is a very large force that the table is under because of the air pressure that's sitting on top of it. But this is just a simple idea of thinking about the air pressure that sits on stuff because of the massive column of air sitting above an object.